Last time, a decision tree asked good questions, but we never said how it chooses them. That's what this lesson is about. The secret is that a tree measures messiness. It always picks the question that tidies up the data the most. Here's the key idea, called impurity. It simply measures how mixed a group is. A group that is all one color is perfectly pure. Its impurity is 0. A group that is half green and half red is as messy as it gets. We can put a number on it with a formula called Gini Impurity. 1 minus the share of green squared, minus the share of red squared. For a 50-50 mix, that comes out to 0.5, the highest it goes. For a pure group, it drops all the way to 0. Lower is tidier. Now watch a tree think. It takes the full, messy group and tries a candidate question. That question splits the data into 2 smaller groups. And we measure the impurity of each new group on its own. To score the whole split, we blend those 2 impurities together, weighted by how many points landed in each group. A bigger group counts for more. That single blended number tells us how tidy this split left things overall. The tree doesn't just try one question, it tries many possible splits. Each one gets its own tidiness score. A poor split leaves both groups still mixed. A great split leaves each group almost pure, and earns the lowest impurity. The drop in impurity, from before the split to after, has a name: information gain. The tree simply picks the question with the biggest gain, the one that tidies up the most. That winning question becomes the node. Then the tree does the very same thing again, on each new group. Find the best question, split and repeat, growing the tree one node at a time. It stops when a group is pure, or when we tell it to stop. That step-by-step, best first approach is called greedy. One quick note, Gini isn't the only way to measure messiness. There's another popular one called entropy, borrowed from information theory. In practice they give very similar trees, so don't worry about the choice, the idea is the same. In scikit-learn, this is just one setting. The criterion picks which impurity measure to use, Gini or entropy. Everything else is the same fit and predict as before. The tree handles all the splitting math for you. So, a tree grows by measuring impurity, and choosing the split that reduces it the most. That reduction is the information gain, and the tree greedily chases it, node after node. Now, a single tree can be shaky. Next, we make it far stronger with a whole forest.